Welcome to the lecture series on 8051 microcontroller. In this lecture, we will be studying about the addressing modes in 8051 microcontroller. So, what is an addressing mode? Addressing mode basically refers to the way data are accessed from memory location, either RAM or ROM. There are 5 ways to do it, and one is called the immediate addressing mode. Then we have the register addressing mode, the direct addressing mode, the indirect addressing mode, and the indexed addressing mode. So we'll be studying each one of them one by one. Before that, let us look into one software, AddSim51. It's a very famous software, and the good thing about the software is that it is available free of cost, and it is used to simulate 8051 microcontroller. So it has got 4 windows. The middle window is basically the editor. So this window is basically the editor wherein you write the program. On the right side, this one gives you information about the ports. So there are 4 ports in 8051: port 0, port 1, port 2, port 3, and each of these ports are having 8 pins. These ports basically acts as an interface between the microcontroller and the external world. So if some information needs to be taken from the external world, from the sensor, so these ports acts as an interface, while any information that has to be conveyed to the external environment, then again these ports are used. On the left side is quite important. It basically gives you the content of the various registers of 8051. We have SFRs, we have the memory locations, all information is conveyed here. And the bottom part basically is about the various peripherals that can be connected to 8051, and the information about those can be obtained from here. Okay, so let's move on. So let's start with the immediate addressing mode. Immediate addressing mode, in immediate addressing mode, data comes immediately after the opcode of the instruction. What is mean by opcode? Opcode basically refers to the mnemonics associated with the instruction, like this move A. Move A is an instruction. Okay, so there is a mnemonics associated with move A. Similarly, move B or move R0 or move R1. So all these are associated with a mnemonics. So the assembly language is not stored in the memory of the microcontroller. The instructions are basically stored in opcodes. Okay, so we will look into it after some time. So let's concentrate here. So we have got one instruction, move A comma hash 35h. So basically what this instruction is doing, it is copying the value 35 it is in hex to accumulator Okay, so after the execution of this instruction, A will be having a value of 35. Okay, similarly the other instruction is not quite visible here, but it is written move dptr hash 3000h. So dptr is an SFR. It basically has got it utilizes two 8-bit registers, dph and dpl, as you could see here. Okay, so after the execution of this instruction, 30 will be saved in dph and 00 will be saved in dpl. Okay, so I have just tried to simulate this code. Okay, org000h. Any instruction in 8051 has to start from this org and followed by the memory address from where the program will be stored. Okay, so here the program is being stored at 000. It starts being stored from the memory location 000h. So the next instruction is not quite visible here, is move A comma hash 35h. This is a immediate addressing mode. instruction. Okay, so after the execution of this instruction, 35 will be saved in A. Oh, and the next instruction is move dptr comma hash 3000h. So 30 will move to dph and 00 will move to dpl. Okay, so here, so it's not correct. I think uh, it's already saved there, so that's why it is showing 05. Actually it needs to be, when you are running the program, that has to be 00. Okay, so let's move. Now come to the register addressing mode. Register addressing mode, in register addressing mode, so it's register content is moved to another register. So take the case of this instruction, move a comma r naught. So whatever is there in r naught will be copied to a. Similarly, the next instruction is move r5 comma a. So whatever is there in a will be copied to r5. Okay, while this type of instruction is not allowed in 8051, move rx comma ry. Rx could be r0 to r7, any register, and ry also 0 to 7. So movement from a general purpose register, any of the general purpose register r0 to r7, to any of other general purpose register r0 to r7 is not possible in 8051. So I have made a video of the simulation of this code in 8sim. Let us see how it works. So there is just you see the editor. In the editor I have written the program org000h. This is the starting point of the program. Then we have move r0 comma hash 25h. This is basically trying to move the value of 25 to r0. Okay, so this is the immediate addressing. Then after that, move a comma r0. So this will move the content of r0 to a. Okay, so this is the register addressing mode. The third instruction, move a comma r0, is the register addressing mode. Similarly, fourth instruction, r5 comma a, is also a register addressing mode, wherein the content of a is being transferred to r5. Okay, so here you could see we have data memory, wherein you could see what are the contents of the data memory when we are running this program. Okay, and we can run the program either directly, okay, by using the run instruction, run the button at the top, or we can use what is called the step-by-step execution of the program. Both are possible. Okay, so let us start. So first we have to write the open the assembly mode of the program. So this is the assembly mode of the program. Okay, so step button and run button. Step is basically to execute the program step by step, one instruction at a time. Okay, while if you use the run button, then the entire program will be executed in one go. So here I am taking the step, I have clicked it, so the first instruction has been executed. So move r0 comma hash 25h has been executed. So after the execution of this instruction, r0 will now be having a value of 25. As you could see here, 25 has been copied to r0. And here also r0 is basically the memory location 01 in RAM. Okay, so here also 25 is there. Okay, so and the program counter, it is showing 2. Why it is showing 2? Because program counter basically points to the address of the next instruction. Another important thing is the code memory. Just see, there is a 1078 25 E8 FD. 78 basically refers to the opcode of R0. It is immediately immediately you have got data 25 there. So 0 0 1 is having 25 value, and then move a instruction is there, R5 instruction is there. So these are having their own opcodes. Okay, so uh, so let's move back. Data memory, this is the code memory, and this is the data memory. Okay, so let's try to execute the next instruction. So next instruction after the execution, whatever is there in A, whatever was there in A has moved to, sorry, whatever was there in R0 has moved to A. So accumulator, now accumulator is having the value of 25. Okay, next step now will, yes, so whatever the content of A was there will move to R5, 25. Now R5 is also having 25. Okay, so okay, that's what that was all about the register uh, addressing mode. Now let's move to the direct addressing mode. Okay, the direct addressing mode. So in direct addressing mode, in direct addressing mode, the content of address is copied to a register. I have taken three instructions here: move a comma 20h, move 30h comma a, move 20h comma 30h. Okay, so please note here that there is no hash sign before 20. That means 20 is not a number, it is a memory address. Okay, so after the I execute the first instruction, move a comma 20h, then the content of 20 memory location will be copied to A. Similarly, in the next instruction, move 30h comma A, the content of A will be copied to the memory location 30. And the third instruction, move 20h comma 30h, in this the content of 30 will move to 20h. Okay, so let us try to see this video. I have tried to simulate these three instructions. So yes, it has to start from org. So that is where the program starts from. First instruction is move 20h comma hash 25h. I am basically trying to save value 25 in memory location 20. Okay, and then I am trying to save 35 in memory location 30. Okay, so because I intend to use the content of 20 and 30, so there should be something in 20 and 30 so that I can use it in my program. So the next instruction is move a comma 20h. So this instruction will copy the value that is there in 20, which is basically 25, to A. Okay, and then the next instruction will copy the value that is there in A, which is 25 now, into the content of 30, and then the next instruction 30 will content of 30 will be copied to 20. So let us start. I press step, so program counter has increased, the first instruction has been executed. So in 20h you could see that 25 has been saved. In next instruction 30, in 30 35 has been saved. Again step, now the content of A is 25. Just see, the content of A is, the accumulator is 25. Okay, why? Because that is the 25 is saved in 20, so that is why the content of 20 has been saved to A. Next instruction, the content of A has been saved to 30 now. Okay, so 25 value is now moved to 30. So earlier it was 35, now it is 25. Okay, so and similarly the next instruction 30 moved to 25. So already 25 was there, so 25 is copied to 20. Okay, so this was your direct addressing mode. So let us move to the indirect addressing mode. Okay, in indirect addressing mode, the address of the operand is given in a register. Okay, look at the first instruction. Look at the first instruction. Move a comma at the rate r naught. So say for example I'm having some value in r naught. Okay, say 25h. Okay, so after this instruction what will happen? So whatever is there in 25h will be copied to a. Okay, not the content of r naught, but the content of whatever is there in r naught will be copied to a. So this is the indirect addressing mode. It somewhat is similar to the pointer concept that has been taught in that is taught normally in C programming, C++ programming. Okay, similarly the next instruction is at the rate r1 comma a. This instruction, in this instruction basically the content of a moves to the content of the memory location pointed by r1. Okay, content of a is not copied to r1, but the content of a is copied to the memory location pointed by r1. And similarly the next two instruction, move x a and move x at the rate dptr. This basically refers to external RAM memory. So indirect addressing mode is basically used to access internal as well as the external RAM. Okay, RAM. I have prepared one video which simulates these some of these instructions. Let us see. So again, it starts from org. First instruction, move r naught comma hash 25h. 25 goes to r naught, then 35 goes to r1. In the next instruction 45 goes to 25, 32 goes to 35. Okay, so now move a comma at the rate r naught. So if I press this uh, one by one, r naught will be 25. Okay, r naught has become 25. Then again I press step, so now r1 has become 35. R1 has become 35 at these two locations, just see here. Next I press step, and now the value 45 has been saved in 25 memory location 25. Then step, then 32 is saved in memory location 35. Okay, then I'm executing this move a comma at the rate r naught. So now the content of the memory location pointed by r naught 25, 25 is having a value of 45, so 45 is now copied to the accumulator. Next step, so whatever is there in a, that is 45, will be copied to the memory location pointed by r1, and r1 is pointing to 35. So 35 will now be having 45, as you could see here. Okay, so that was your indirect addressing mode. Finally move to the indexed addressing mode. So indexed addressing mode basically uh, refers to accessing the internal and the external ROM of the 8051. Okay, so you will wonder why external RAM and external ROM and internal ROM need to be accessed, because they are permanent memory. They are codes. Why to alter them? Basically we are not altering the codes, we are actually trying to access the content of data content of the ROM. And I had already told you that ROM can contain some important data that are regularly used in a particular program. Okay, I had given the example of the street light. Okay, so access data from code memory, internal or external ROM, and the permanent data which are stored in lookup table, and they are accessed. Okay, so just see the syntax. Move c is the code used, is the instruction used. Okay, move c a comma at the rate a plus dptr. So the content of a and dptr are added, and the memory location pointed by the addition of these two registers, the content of that will be copied to A. So this is how it works. Okay, so ea value, ea bar value will basically decide whether internal ROM or external ROM is being accessed. So that's the end of this lecture. Thank you for watching it.